Today we are going to touch the review problems for the chapter 2. So first one is 2.37. 2.37. 2.37. A.
Maybe like if you want to buy this book, link will be in the description.
Yeah, I know that. What is the problem?
The problem is
4 minus 8
parentheses minus 2 parentheses to the 2 power minus 4 parentheses negative 3 parentheses.
Okay. Usually to evaluate this one, you have to use PEMDAS, right? You guys know the PEMDAS, right?
Yep.
Okay, but I just skipped some steps like this way. You can first touch this one. What is it? Negative 2 squared is?
Negative 2 squared is negative
Please.
4.
Just 4.
Right.
And then 4 times negative 3 is?
12.
Negative 12, but there is a negative sign, right? Subtraction, right?
Mm-hmm.
So it becomes plus 12. Understand me?
Yeah.
And then you're going to multiply by 8, subtract from 4, right? 4 minus 4 plus 12 is 16. 16 times 8 is?
108 or something like that.
You can also this one understand like 2 to the 7th power. 2 to the 6th power is 64. So this one's 120. 28, okay? So the answer is?
The answer is
Negative 124. Good. Keep going to next one for B.
B is parentheses 5
minus 2
parentheses to the 2nd power plus parentheses 2 minus 5 parentheses to the 3rd power.
Third power. Okay, for the first part, 5 minus 2 is 3, right? You want to do 3 squared, and then plus 2 minus 5 is negative 3, right? And then cubed. Okay, 3 squared is 9 plus negative 3 squared is negative 27, right? So the answer is must be negative 80.
Oh, can I go wash my hands?
Okay, we're going to touch C. What is it?
5 times 2 to the 5th power minus parentheses 2 times 3 parentheses to the 2 power.
Whole thing squared, right?
Mm-hmm.
Yes. This time you can first touch the 2 to the 5th power. Okay? What is it?
That would be.
I said you just memorize it. 32. Okay? Please. And then 2 times 3 is 6. Square is 36, right? Yes, even though you get the other idea, but simply we just evaluate this one. Simplify. 5 times 32 is 160, right? Minus 36. You just keep the 100. 60 minus 36 is 24, right? Next one is 5. Okay, I can wait for you.
D. Oh, we're waiting for.
For D, they just want to evaluate 5 plus negative 6 cubed. That you just keep thinking for the next step, okay? And then 2 times 3 squared. Okay, for this one, You can first evaluate this one and this one, and then divide, you know? What is negative 6 cubed? At that time I said you first think that the result is negative or positive. Is it positive or negative?
Positive.
Please.
Negative?
Negative times negative times negative is
Right,
negative.
negative,
Okay.
right.
It depends on the power is even or odd, okay? 6 squared is 36, right?
It doesn't depend on the amount you're multiplying it.
Yes.
into.
You will touch this problem in 39. Okay. So what is 6 cubed? I already determined that the result is negative.
Cubed is
6 squared is 36. 36 times 6, but
216. 216.
you said 216. 36 times,
36.6.
you already get the 180. 30 times 6 is 180. And then you just add up to 36. 200?
216.
Yes, 260. And then you're going to divide it by this one, you know. But I don't want to like multiply this one, even though you can first doing this one. Let me check that.
So that's 18.
This one is
18.
18. But this one means 5 plus exactly negative 216 divided by 18, right?
Yeah.
216 must be divisible by 18, right?
Yeah.
Because 216 is 6 cubed, right? If you first divide it by 6, because that one is easy, okay? This one is 3, this one must be 36, right? So, negative 36 divided by 3 is negative 12, right? So, which is negative 7, right?
I think that should be 5 plus, and then parentheses negative 12.
Yes, which means 5 minus. Same thing. Even though we just evaluate the negative 6 cubed, and also we just evaluate 2 times 3 squared, right? But I don't like it. Let me check that one. Negative 6 cubed, you can write down the, must be negative, right? 6 cubed means 6 times 6 times 6, right? And the 2 times 3 squared is 2 times 3 times 3, right? So, without evaluate like this one, 216 and 18, you just reduce it. Cancel out. Can you see? And this one cancel out, right? So 2, right? So 2 times 6 is 12. You understood? So when you simplify, when you evaluate this type of expression, even though you can evaluate each part and then simplify, but you can see, if you can see the like big picture, without the evaluate some part, you can easily simplify that. You guys understood?
2.38.
Yes, 2.38. By how much does 3 to the 5th power exceed 5 what?
5 to the 3rd power.
5 cubed. So which means you have to evaluate what? Which one is greater?
You have to subtract 3 to the 5th power with 5 to the 3rd power.
Yes. So you have to 3 to the 5th power minus 5 cubed, right?
Yes.
From this one, I'm going to generalize something, okay? Even though I don't want to prove that one. But that you can test this one. First one is base 3. For second one, exponent power 3, right? For the first one, power is 5. But for the second one, 5 is base, right? That time, you can think of some other result, okay? Okay, anyway, I want to first evaluate this one. What is the 3 to the 5th power? That time you can first think the 3 to the 4th power, okay? 3 to the 4th power means
Wait.
3 squared. So 9 times 9, 81. Right? 81 times 3 is better. So 81 times 3,
would be
243. Okay, how about 5 cubed? That one is just kind of popular number. What is it? 100.
5 times 5.
So 125, right?
100.
So the result is, this case, I just looked 100 digit first. 200 minus 100,
118.
100. 43 minus 25 is,
2.
you said 18, right?
Oh.
Okay, from this one, you can say this one. If B is greater than C, that time, yeah, both must
Do we
be like,
write this down? If B is greater than C.
yes.
Okay.
But both are just a positive integer, you know? Positive. I just touch it like a little special case, okay? Integer. Then you can say this one. Higher power make the great number. I mean, C to the B's power and then B to the C's power. Which one is great? Power is great, one is great, okay?
More power.
Like
is
this, yes, like this example. 3 to the 5th power and 5
5 to the
cubes.
3rd power.
Yes, okay? You can also check the, like a little bit simple example. Could you give me that? Like 4 to the 5th and 5 to the 1st, okay?
4 to the 5th is greater.
Yeah, 4 to the 5th is like what? 2 to the 10th power, right?
Mm-hmm.
You guys already memorized 2 to the 10th power is
1024.
1024. 5 to the 1st power is 5 squared and squared. 5 squared is 25.
625.
Yes, 25 squared is easy. 625. If you forgot this one, you can watch the other video. So basically like this one. You understand me?
Yes.
Okay. For like this problem, yes, you can easily solve this problem, but you just try to generalize like this concept. When you see like this type of number, oh, 5 cubed and 3 to the 5th. Is it true for the general case? Even though this time I didn't prove it, but you just accept this result, okay? Yes, so 2.39.
What is
Okay,
of
this
the
one for the like 1 or negative 1 to the some power. Before doing that, I want to first remind you that, okay? 1 to the any integer power, including negative integer, any number, always what? Just 1, right? But for the negative 1 to the some power, there are 2 cases, you know? What is it? If n is even,
it will get 2.
always 1, okay?
It's
Yeah.
negative 1.
If it's odd, it will be
Yeah.
negative 1.
This is negative 1, you know? And also, when you evaluate the negative number to the some power, that time you just check the what is the exact base, okay? Which means you just check the parentheses part, okay? I want to first copy it. Negative 1 to the 2004, right? Next one is, oh, for the first one, there is no parentheses, but for the second one, there is parentheses, right? Which means base is 95. For the third one, 1 to the 2006. And for the last one, minus, 1 to the 2007, right? Okay, for the first one, you first evaluate 1 to the 2004. Always I said 1, right? But there is a negative sign. For the second one, oh, base is negative 1. Negative to the other power, always negative 1, right? For the third one, this one always 1. For the last one, just 1, right? Understand me? You can first eliminate these two things. 1 minus 1 is 0. You just add up to negative 1 plus negative 1, which is negative 2, right? You understood? Number 2.40. They want to find for what positive integer n is n squared, sorry, n squared equals 2 to the 6th power. Even though you can evaluate the 2 to the 6th power, which is 64, right? N squared is 64, yes. N is 8. A squared is 64, right? But I want to just touch it like the big power things, okay? The larger power. To understand the other type of one, even though we can solve like that way, but I just want to rewrite. The left-hand side is n squared, right? I'm going to rewrite the 2 to the 6th power as what? Something squared, okay? N squared is 2 to the 6th power means 2 cubed first and then 6 squared, right? So which means n is basically plus minus, but they want to find only positive integers. So you just evaluate to 2 cubed, okay? So which is A. Understand me? At the beginning of this problem, yes, you can use the 2 to the 6th power. I know that one, which is 64. But for this problem, that way is not good. I mean, x squared is like a 2 to the 100th power. What is positive value for n? 2 to the 10th power is a little bit big number, okay? Exactly, that one is a 31 digit number. Yes.
To the second power.
Yes, you just rewrite n squared equals 2 to the 100th power is 2 to the what power squared? 50, right? So n must be 2 to the 50. This case is just n squared, but you can also touch the n cubed, n fourth, like that one, okay? I want to give it another example. N cubed equals 3 to the 120th power. That how can you find n?
You could do it by doing it n third would equal 3 to the 60.
60?
3 to the
Cubed.
60 cubed and
The 60 cubed is
no, not 60 cubed. I was gonna do 60 and then to the second power.
but this is cubed.
Then
So this one must be 40, you know?
40.
4
Yeah.
times 3 is 120, right? So n is 3 to the 40th power. You guys understood?
Does it have to be cubed? Oh yeah. It
Yes,
has to be cubed.
you just check the power, okay?
Yeah.
Okay, number 2.40. What year in the 20th century? 20th century means the years 1901 through 2000 was a perfect squares, okay?
So are they saying put the year into like
Yes.
powers?
Even though they just say the 20th century, but you just think like those numbers, 1901 through what?
1901 through 2000.
2000. You just try to find perfect squares, right? You can first think what is the smallest, I mean least perfect square greater than 1901. That you just think some numbers like 40 squared is
40 square foot.
yes, you can first touch the 40 squared, which is
Oh.
1,060.
1,060.
1600, right?
Yeah.
And then even though you can touch the 41 squared, but I'm gonna first touch the 45 squared, okay? Because you can easily evaluate this one. How? 4 times 5, right?
Ends in 0 or 5 or 25. Wait.
Yes. So 4 times 5 is 20, right? And the last digit always 5 squared, 25. Oh, this one is already greater than 2000. So which means between 40 squared and 45 squared, you can get the perfect squares, right? So you can first try it like a 41 squared, right? But last time I said 41 squared means 40 plus 1 squared, right? This one means 40 squared, 1600 plus 2 times 40, 80, okay? Plus 1, so what is it? 1681. Oh, that's not good. But the last time I gave you an idea from between the two consecutive perfect squares, that time you just add up the consecutive odd numbers, okay? From the 40 squared to 41 squared, you just add up the 81, right? To get the next one, 42 squared is, you just add up the next odd number of 81, which means 83, okay? So you will get 1764. Understand? To get the next one, you just add up the 85, okay? This is idea. So what is it? 1849. Oh, still less than the 1901. To get the next one, you just add up again. What? 87, which is 1936, right? This is good. This 1936 is, this one is 42 squared. This is 43 squared. So this one is 44 squared, right? Only one perfect square, 44 squared. 45 squared already, 2025, right? From this number to this number, to check that out, you just add up the 89. That time you will get the 2025, okay? Even though you can use like perfect square things, you can try the, 44 squared is 44 times 44. But if you know the like perfect square numbers, kind of the pattern, how can you get the consecutive perfect squares? You just keep adding next other numbers, okay? Using that idea, you can easily check that out, okay? For you, I just want to show you something, okay? I just add up the odd consecutive odd number, okay? What is 1 plus 3?
4.
4. 4 is 2 squared, right? Plus 5 again?
9.
9 is 3 squared, right? And the next odd number 7. 16. Oh, 4 squared.
Wow.
You understand me?
Yes.
I just want to add up the like,
So add them up by 2 and then just.
okay, I just want to write down the 99. That you just consider how many odd numbers? 1 through 99. How many odd numbers? Totally 50 odd numbers, right? So some of those first 50 odd number must be 50 squared, always perfect square number. So this one is 2500. Simple.
How do you do
Next one, number 40, 42. What is the value of x to the fifth minus 2x? Okay? When x equals 3. Okay? You just substitute. 3 to the fifth minus 2 times 3, right? What is 3 to the fifth? 3 to the fourth is 81. 81 times 3 is 243 minus 6, right? So which means 240 minus 3, because you can first subtract 3, so 237, okay? Even though this is just simple subtraction, but I just keep talking about how easily evaluate this one, you know? Next one, 2.44. How many possible perfect squares are less than? Oh my God. How many perfect squares?
into that are less than 10? Oh.
Less than
I didn't
10,000. But this one is not hard one. You can first think like what? 10,000 is something squared. Is it true?
Yes.
What is it? 10,000 is?
10 to the 1
Yes, you
to
can.
10 to the 4th power.
10 to the 4th. Oh, this one also perfect square number. Like what? 10 squared and squared, right? Which means that this one is 100 squared, right? So our perfect squares must be 1 squared through 99 squared, right? So totally how many perfect squares? 99
I mean 99. Yeah.
perfect squares. Yes, so simple you can understand, oh, 10,000 is just 100 squared. Yes. But sometimes you can use this idea. Oh, 10,000 is 10 to the 4th. 10 to the 4th means 10 squared and squared, which means 100 squared, okay? For the little bit higher number, big number, you know, you can use this idea.
I have a
Let's go to the number
number.
45.
Yes.
Oh, I just skipped the number 43. Okay, 43.
Oh.
Sorry about that. Number 43. If x is negative 4, and then they want to evaluate negative 2 times x cubed.
Wait, 43, number 43?
Yes, 43
Didn't we
minus
do
3
that?
No.
X
we
is
did
squared.
42.
and 44. Sorry about that. But we can do 43, okay? So this one is negative 2. Oh, x is negative 4, but you have to cube. That time you have to make the parentheses, okay? This time base is negative 4. For the next one, negative 4 and squared. This one is negative 2. How about the negative 4 cubed? I said you first think that the result is negative or positive. In this case, negative, right? Negative number to the outer power always negative. 4 cubed is, you guys already knew, 64, right? Minus 3. Negative 4 squared must be positive. 4 squared is 16, right? First one is just a positive. 2 times 64, right? Minus 3 times 16. Yes, you can evaluate the 2 times 64 and then 3 times 16. I can accept it that way, even the other way. Anyway, 2 times 64 is 128, right? You just recognize that 128 is 2 to the 7th power. If you recognize 64 and 2, you just first write down the
Why is
128.
128 a really common number?
Because this is a 2 to the 7th power. You just saw a lot of times of the 2 to the 7th power. Even though they didn't say 2 to the 7th, but 2 times 4 cubed. 2 times 2 to the 6th. Oh, that one is a 2 to the 7th. Because
What is
like
that
this one.
called? What is that pen thing called with the...
And then you just evaluate 3 times 16. What is it? 48, right?
Yep.
So this one must be 80, right? For this subtraction, even though you can do, but when you subtract 48 from the 128, I want to first subtract to 28 first, okay? So 100 left. 100 minus, you have to subtract 20.
Yes.
So 80.
Oh.
Don't use like a vertical method, you know?
Yeah.
Okay.
Okay, look at the number 45. Let n be a positive integer. If, oh my god, look at this one. They gave the like a kind of the strange formula. Hopefully you guys like this formula. Like what? Holy. Yes, 1 plus 2 plus
3 plus 4 plus.
keep going to what? And right? We just get all. You first evaluate the sum of the first n positive integer and then square it, which is always equal to what? Sum of the first n perfect cubed. Oh, is it true? You just wondered that, but they just gave this formula. Using this one, oh, this is not formula, okay? You just try to find the value of n. I'm sorry. something's wrong. This is not n.
Can I go to the bathroom?
This is 6. So there's just some minutes left, you know. Would you first evaluate 1 plus 2 plus 3 plus
4 plus 5 plus
6? What is it? 1 to the 4, 10, right?
Yes.
So 5 and 6, so which means 21 squared is 1 cubed plus 2 cubed plus 3 cubed, like this way. Understand? What is the 21 squared?
21.
Squared is 441. And then you just check those values. What is 1 cubed? 1, right? 2 cubed, 8, right? And 3 cubed, 27. 4 cubed is 64. How about 5 cubed? 125.
Yes.
How about still less than like 441? So you have to think the next number. What is 6 cubed? 6 cubed is 216, right? This part already what? 300, right? Might be. Or you can say must be. To the what? 6 cubed.
Yes.
So satisfy this formula, n must be 6. Okay? I didn't evaluate the 1 plus 8 plus 27 plus like those things. You know? You can easily guess it. This is 100, this is 200. You can get the 300, right? This is a 64. I mean, this is 60, this is a 20, this one is a 20 again. So you will get the another 100, right?
I see this.
Shift. You just check the only one digit, okay? 8, 7, 15, this is 5, unit digit 0, right? This 4 and 6, already 10, right? So unit digit must be this one. Oh, this is 1. Okay, we have to add up them. This one is kind of the number sense, okay? You can test those numbers, yes. Some of the first perfect cubes make the like 441. Okay?